Today we'll try to understand what's the difference between iterators and generators in Python. As you can see from its name, it's something related to iteration. So, for example, you can iterate over collections, over list or over dictionary. But what does it actually mean? Iterator is a class which implements iterator protocol. That means that our class implements dunder iter and dunder next methods. Dunder means double under. That means that method's name starts with double underscore and ends with double underscore. So, if we create this class, let's try to understand what do these methods mean. Dunder iter returns an instance of our iteration object, and dunder next returns each next element on each call. For example, let's look into class even numbers, which returns even numbers. We need to implement, as we know, we need to implement two methods, dunder iter and dunder next. Here, dunder iter, and we establish and we initialize starting value, well, with 0, and return self object. We return instance of our class. And dunder next, we want to return only even numbers, so that means that on each call we increase our value by 2 and return our value. Great. Okay, our class is iterator. How can we check it? How can we check that our value is correct? That's pretty simple, because there are built-in functions iter and next. Iter calls dunder iter methods, and next calls dunder next method. That means that if we want to iterate over elements from our iterator, we should do the following. Create instance of iterator and call next function several times. As we can see in the output, it returned 2 and 4 after 2 calls of next function. That is exactly what we wanted. We did it. We implemented our iterator which returns even numbers. As you can see, there are no limitations, so we can call this function many times, and on each call it will return next value, and that will be infinite process. We are not ready for such things, so let's try to limit our iterator. We'll define max value equal 2, we'll define max value, which equals 10, and on each call we'll check. If our value is still less than 10, we'll return next value, otherwise we'll raise stop iteration exception. Stop iteration exception means that iteration is over and the iteration should be stopped. Now, when we define the upper bound for our iterator, we can call our iterator, for example, inside for loop. A for loop implicitly calls the same functions iter and next. You just can't see it from your code, but in fact, when you start your loop, it calls iter and creates instance of iterator, and on each call it calls next function until stop iteration exception is raised. So, as you understand, if we didn't have this limit with max value, our loop would be infinite, and that wouldn't be really pleasant. But in our case, we have a limit, so after iteration over elements in our instance of our class, we received the following output: even numbers from 2 till 10. This is how iterators in Python work. Okay, now let's try to understand how generators in Python work. What does this term mean? Generator is a function which has a yield keyword inside its body. For example, we can define myGenerator function, which does something similar, which iterates over a number and returns only even numbers. Yield function means that the value is returned from this function on this place, but it just suspends the execution of this function. So on the next call of this generator object, it doesn't start executing your function from the very beginning. The execution will continue from this place, where the yield called returns some value. And as you can see, we should do something very similar. So on the first call, we create generator object, like we did it with Iterator, it return Iterator object. And again, we can call built-in function next, and on each call, our generator will return next value. Here we called it 2 times, and it returned 2 and 4 numbers. Again, let's try to set a limit for our generator. We can reuse the same number max, which equals 10. And if value is too big, we just return. If we return something from generator function, internally it raises the same stop iteration exception, and after that you can't call this. After that, this generator won't return any new values. Let's check how it works. Again, we need to create generator, and after that, when our generator isn't infinite, we can use it inside for loop. And again, for loop internally calls the same functions, so it understands how to internally it calls next function for our generator and returns values from 2 till 10. You might notice that without limitation with max number, our iteration would be infinite, and you can see that it executes values lazily. So the next value will be generated only when someone called next for your generator, and the same is true for Iterator as well. That's really cool feature of iterators and generators. Also, there are iterator expressions, which are very similar to comprehension expressions, like there are list comprehensions or dict comprehensions, when you can initialize values in your collection in one line. You can replace square brackets with these brackets, and the result will be a generator object. You can see here it is a generator object. And again, for this object, you can call next function and get values from our generator. Here it returns squares of numbers from 0 till 10. So, in fact, as you can see, generators and iterators are very similar objects. And in fact, every generator is an iterator. Iterator is a more wide notion, I would say. But generators are more powerful objects, I would say, because first of all, you can call sub-generators with yield from expression. You can get some values from other generator and pass them as a result of the current generator. Also, there are advanced functions like send, accept, or stop. Send allows you to send some data to generator. So your yield expression will return inside generator, will return argument which was passed to send function when you call this generator. Also, accept function will raise exception inside your generator function, and stop function will raise stop iteration exception. So it's just you can stop generation process outside of generation function, and which is really very cool and useful. And of course, there are async generators. If your function is asynchronous function, so you defined it with async def instead of def, your generator will become asynchronous generator, and it will turn your generator into coroutine, a lightweight thread which will execute your code asynchronously. But it's a big separate topic which I'm not going to cover in this video. So, but this feature exists and available for generators. So all this shows that generators are big and powerful objects, which gives you a lot of opportunities when you write your Python code. So let's try to answer to the question from the beginning of our video. What's the difference between iterator and generator in Python? Iterator is a more general concept. So each generator is an iterator, but not vice versa. Iterator, an object which implements iterator protocol, which means that it has dunder iter and dunder next methods. Generator is a function which has yield expression inside its body. And both these objects generate items when you call next function for each of them, but the generator has much more features. Most of them are related to yield keyword, which allows not only return information to the caller, but also received information which was sent with send function. And you also can turn your generator into asynchronous generator, coroutine, and execute your code asynchronously. Thank you very much for your attention. I hope this video is helpful for you, and see you in the next video.